Okay, so we're going to continue on with section 6.5. So this is 6.5 lecture part 2. This is your shape sheet. So VSEPR molecular geometry, this is what you will get to use to determine the shapes of these small molecules. And just to sort of review here, I did mention early on that linear, when you have two atoms bonded to each other and that's it, you really don't have a central atom. So in terms of atoms bonded to the central atom and lone pairs of electrons on a central atom, that's 0. So anytime you have just two atoms bonded to each other, it's linear. The bond angle is 180. Now here's linear where you do have a central atom. So you have the central atom here, one atom bonded here, one atom bonded here. And so you have two atoms bonded to the central atom and no lone pairs, still 180. Okay. Here's that bent that I mentioned at the end. It's sort of in the trigonal planar family, but it has two atoms bonded to it and one lone pair. This angle here is a little bit less than 120 because of this lone pair angling or bending those a little further down. That's that valence shell electron pair repulsion. Okay, here's your trigonal planar, 3 and 0 is 120. This one just happens to be laying kind of flat this way, but it is flat, it's planar, and all these angles are 120. Here's next is your tetrahedral, which has 4 atoms bonded in no lone pairs. That bond angle is 109.5. These two are very closely related to that tetrahedral shape. It's tetrahedral in what we call structural geometry, not really in the shape, but trigonal pyramidal, 3 atoms bonded, 1 lone pair. That angle shortens a little bit to 107. And then finally bent with 2 lone pairs and 2 atoms bonded like a water molecule. It's around 104.5. So that one's 2 and 2. So what you basically have to do, and we'll talk about this here right now, is draw the Lewis structure, okay? And then from that Lewis structure, then you have to examine it and answer these 2 questions. How many atoms are bonded to the central atom and how many lone pairs are on that central atom? And once you do that, you can determine the shape. And then you kind of have to sketch it in that correct shape, okay? As best you can in 3 dimensions. All right, we have to make sure that we don't make a tetrahedral like a flat plus. We have to make sure we angle those down. And I'll kind of show you how to draw those here with our examples. So here's all of our examples. So they're all just an example of each different shape that we have. And on this next page, I'll kind of talk about each one of those. So if you'd like to first go through and draw the Lewis structure for each of these, just as some practice, you could, because from that Lewis structure, we're going to determine shape. Okay. So you could pause and do that if you'd like. If not, we'll move on to the next page to look at these answers. Okay. So what I did up here, I just labeled B for bonds and LP for lone pairs, just to make sure you could see why we got the shape that we did. Okay. So the H2 is linear. And we got linear because we have H bonded to H. It's just 2 atoms bonded together. This is, sketching the shape. Really, it's called a ball and stick model. Really, the only difference is we just draw a circle around here. If we were in class, we would be using the model kits to actually make these little models to take a look at them. But we have to do our best now here remotely. Your angle is 180. There really aren't any bonds to the central atom or any lone pairs on the central atom because it's just 2 atoms bonded together. Okay. The other example of linear where you do have a central atom is CO2. Now here's your Lewis structure for CO2. So that's kind of what we learned to draw in section 6.2. 2 double bonds, 1 double bond carbon to oxygen, 1 double bond carbon to oxygen, your lone pairs around oxygen to finish out your correct number of valence electrons. Okay. A couple of things about determining shape. You only look at the lone pairs on the central atom. So when we go to look at this Lewis structure to determine shape, we have 2 atoms bonded, and that bond can be a single bond, it can be a double bond, it can be a triple bond. It still only counts as 1 atom bonded. So we have 2 atoms bonded to the central atom and no lone pairs. That's why I write 2B and 0 LP. So it is linear. So this bond angle right here is 180 degrees. So we just draw it straight across. You don't need to include the lone pairs on the oxygens because it's not on the central atom. It's not determining shape. And you do show a double bond with 2 dashes. Okay, so there's the correct sketch of the molecule of CO2. Okay, our next example, COH2. If we draw the Lewis structure, you'd have a single bond carbon to hydrogen, single bond carbon to hydrogen, double bond carbon to oxygen with the lone pairs on the oxygen. Now, carbon's in the center. Okay, so it has 1, 2, 3 atoms bonded to it, and just for the carbon, no lone pairs. So it's 3 and 0. That is trigonal planar. Okay, that is trigonal planar. That is 120 degrees in terms of its bond angle. And here's how you would draw that. Remember, it's like a pyramid, or excuse me, I should say a triangle. We show a double bond to oxygen with the 2 dashes, single bond to H, single bond to H. Okay, it's not like a T, it's not like a flat T. It looks like a triangle. So 3 bonds, 0 lone pairs. All of these angles are the same, 120, 120, and 120. Okay, now let's jump up here to CH4, our next example. Pretty simple Lewis structure, no lone pairs around hydrogen, just 4 single bonds, hydrogen to carbon. So if we look at this Lewis structure, it has 4 atoms bonded to the central atom and 0 lone pairs. So that means that it's tetrahedral in shape. So note how I tried to draw this. So you sort of have, and you saw this in your POGIL when you did this yesterday, that they show like kind of with like a darker line here and some dashed lines. If you want to do that, you can to show a little more dimension. But I just kind of show, this one's here, here, and here, and this one's going off the top. So you have 4 bonds and 0 lone pairs. Like I mentioned before, I wouldn't draw it like a flat plus. It's not that shape. This is trying to show those 3 going down and then 1 off of the top. Okay. Now, closely related to the tetrahedral shape is the trigonal pyramidal shape. So NH3 is an example of that. Here's your Lewis structure. You have nitrogen in the center with a lone pair, and your 3 single bonds, nitrogen to hydrogen. So when we examine this Lewis structure, we have 3 bonds to the central atom and 1 lone pair. So there's that 3B and 1 LP. So when we draw this, we draw it very similar to the tetrahedron up here, the tetrahedral shape, except we put a lone pair off the top. Okay, and remember that lone pair, that valence shell electron pair, angles these down a little bit further. You don't have to draw it any different really, but it is 107 degrees instead of 109.5. Okay, so that's the trigonal pyramidal shape that you have with the lone pair off the top. And the last 2 are 2 different bent molecules. Okay, this is our first. ONH is an example of that molecule. When you draw the Lewis structure, you have nitrogen in the center, double bond to oxygen with 2 lone pairs. You have a lone pair on nitrogen and then a single bond nitrogen to hydrogen. So remember, you're only looking at the central atom. Nitrogen is in the center. It has 2 atoms bonded to it and 1 lone pair. So 2B and 1 LP. So it is bent. It's still in this trigonal planar family, but instead of having a bond here off the top, it has a lone pair. So you have your double bond to O, so we show a double dash, and we have a single bond to H. And this bond angle here changes a lot with what atoms are actually bonded here, but just know it's less than 120. This valence shell electron pair angles these down a little bit closer together. And then finally, your bent in terms of the tetrahedral family. Water is a good example of that. So here's your Lewis structure for water. 2 hydrogens bonded to the oxygen and 2 lone pairs on oxygen. So it's 2 bonds, 2 lone pairs. Okay, so it is bent in shape. And I still tried to maintain that sort of tetrahedral shape, but putting a lone pair here and a lone pair here. Really, the molecule is just like right here, but this is like an area that's real negative over on this side. Water is very polar. Okay, and this angle here is around 104.5. Like I said, I think your book uses just 105, but for water specifically, it's 104.5. Okay, so just in terms of what you have to do with your homework and with drawing these, you first have to draw the Lewis structure. Then from your Lewis structure, determine how many atoms are bonded to the central atom and how many lone pairs are in that central atom. Use the sheet, the VSEPR molecular shape sheet, to determine what shape it is, and then try to sketch it in that shape. Okay? So that's what you have to do for homework for tonight. I think there are 8 of them, maybe 10, 8 or 10 that you have to draw out. So draw the Lewis structure, determine the shape, and then sketch it in the shape. Okay?